Most classes that we design would require assignment, possibly comparison, some other forms of comparison, and this is what we actually did in our Java-like string example with all of these operators and also, of course, assignments. Classes that represent numerical values gain natural syntax from arithmetic operators, as we discussed. String classes provide pluses, plus equal for concatenation, and also typically index access for individual characters. So I think in a few minutes we'll try to do this in our string class to enrich it with character access through subscript operator. Consider also a possibility that we have a class name phone book. So it contains essentially names of users and their phone numbers, something like this. So it's possible to overload the subscript operator, not just with the subscript, which is a numeric, like an integer, but also the subscript, which is a key. So in general, the idea of a subscript operator is that when you have two objects, A subscript B, okay, so if you want to overload operator, subscript operator, it gets resolved. This expression right here, right? This expression A square bracket B square bracket is resolved as operator, which is named subscript, right? So that's just the name of the function, and it takes the type of A, right, and the type of B as the parameters, right? But that's an idea that operator, subscript operator like this, is a binary operator, right? It always requires two things. However, it cannot be implemented as a standalone function, right? Because there is a rule in C++ that operator subscript must be a member function of your class. And with this in mind, basically this is just a concept that we discussed, but in reality it has to be used as a member function of our class that takes only one argument. Okay, so instead of taking two arguments, there's just like one argument right here. So this becomes the argument for implementation of the subscript operator. So we'll talk about this when we use an example with our string. Increment and decrement operators, both prefix and postfix, can be implemented and can be overloaded. So you can define plus, 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 and minus, minus for your objects. And in your implementation, it is required that these operators, both plus, plus, and minus, minus, have to be member functions. And the practical approach is that you just essentially with this rational class example, remember there's a numerator and denominator, so we're just manipulating those things, and when we are incrementing and decrementing, we're basically relying on these parameters right here. So but both have to be implemented as member functions, and the prefix version, which is this version, minus minus a, right? So this is the prefix version, does not require any parameters. And of course, the operator function is invoked for this object right here, object A. But if I want to use b minus minus, which is the postfix version of the operator, we use like non-existing parameter int. It's just used to resolve the difference between postfix and prefix like this. So it's parameter that's never used and is never actually given anything. It's just completely ignored by the compiler. It's just it's the only way to distinguish between the two. Also important to note that this is an example of decrement operator, and this is the prefix version. So the prefix version requires an L value. The postfix version does not have to be an L value after all. So these are the syntax, of course, is just this little technicality of using an int as a parameter, which is not used, only to make a distinction between the prefix version and the postfix version for the compiler to use when it parses through your expressions.